Welcome to Math Mini Lessons. My name is Sarah, and in this video, I'm going to show you how to pass the Algebra 1 Regents. So watch this video. I'm going to first give you some links in the description that have the exam itself, this exam for this video, and this calculator right here that you're also going to see me using for different types of questions. Then you should just take this test yourself, or just take the questions that you're not sure of to try them out on your own and then come back to this video. For the breakdown to video, know that I'm going to have 24 multiple choice questions. You know that's coming up at this point in the year. They're each worth 2 points. You have 6 open response worth 2 points, 4 open response worth 4 points, 1 6-pointer, and all that is equal to 80 points. So once you finish, you're going to add it all up and figure out how many points would I have gotten if I had taken that test today. And with that, I'm going to help you convert it to see what that scale score would be, to see if you have enough to get a passing score of a 65 or higher, or if you're going for a level 4 or level 5, you're going to be able to figure out exactly what this is, how many points you would need for each one. So I'm going to give you that raw score to scale score conversion. But that's it. This video is to help you study. So first, try it yourself. Stop here, take the test yourself, and then let's start clicking in. I'll show you some answers, and stay on if you need some help. All right, let's jump right in. Let's look at the answers for 1 and 2. The answers are 4 and 2. Check off with your work. If you have them correct, move to the next chapter. If not, let's stay where we are. We'll start with the first one, and let's dive in. A ball was launched into the air, and its height above the ground was recorded with each second as shown in the table below. Based on the data, which statement has a valid conclusion? So my plan for this one is I'm going to sketch the ball. Or really the height of the ball over time. Okay, so here's time. At 0, we know that this means the ground, and time is going to be in seconds. So we have 0, 1, 2, 3, 4 seconds. And I noticed that the ball is really starting at a height of 11. So it's starting, and I get to make this up. This is at 11, and then it goes up to 59, and then it goes up again to 75, and now it starts to fall down to 59 and down to 11. So it's making, this is just again a sketch, it's making that upside down parabola. So I have to figure out which of these is true based on the sketch part. So again, I'm just eliminating and just giving reasoning. So with the first one, the ball lands at the ground at 4 seconds, and I know that's not true because at 4 seconds the ball was 11 feet high. So no, that doesn't matter. The ground would be when the height equals 0. So that's not true in this case. In the second one, we have the ball reaches a maximum height of 11 feet. And I know that's not true either. The maximum height was 75 feet. And the third one, it says the ball was launched at 0 feet. So no, when I'm here, when the ball is launched, it's at 11 feet. So that doesn't work. And the last one, the ball reaches its maximum height at 2 seconds. And that makes a ton of sense because at 2 seconds, the ball is at the highest part, 75. And I can also see it here on the chart. So I liked having a sketch. Notice you could have just looked at the chart to get the answer, but I thought a sketch would also be helpful. Let's look at the second one. And here, this one is just via systems of equations. And I know that just because I'm literally just looking at the problem and noticing over here that I have 2 equations in each one. And I have conditions here where I have multiple variables and things happening. So let's jump in and see what's happening in the problem. We have a tour bus that can seat at most 80 people. So this is going to be the bigger number. I'm going to put a plus sign. Adult tickets cost $18 and child tickets cost $12. The bus company must collect at least $650. So this has to be the smallest number is the 650. If A represents the number of adult tickets sold and C represents child tickets sold, what is the system of equations? So my plan for this one is to represent with two equations. That's my plan. So I know, first I'm talking about the passengers, and I know that the adults plus the kids, and I know that at most 48. So that means the biggest number here has to be the 48. So I can have an equal of 48. I can have exactly 48. But the most I can have is 48. This has to be the bigger number here. So notice how I'm aiming my symbol in that way. And the second set of numbers has to do with money. And I know that it has to do with the profit part. So I know that for the adult tickets, $18. So 18A plus 12C. And I know that I have $650. All right, so now we have to think, which one do I want to be the most? Now it's saying that at least 650, so the 650 is at least, which means this part has to be the most. So I'm going to aim my symbol this way. But I can ask, can it be equal to 650? Yes. So the least amount it could be is 650, or it has to be greater. So these are my two equations, and I can see that this matches with 2. Right over here. So notice how I kind of use those pluses and minuses to help me figure out which direction I want. And when something is say at most, that means that number, that value, that expression has to be the larger of the two expressions. If it's saying at least, that means that expression has to be the smaller. It can be equal to that, but it has to be the smaller of the two, equal or less than. All right, so hit pause and jot this down into your notes. All right, let's look at 3 and 4. The answers for these are 1 and 4. So jot them down. If you have the right answers, move to the next chapter. All right, the first one, these are just exponent rules. And for these, we're really looking at product of powers. And that pretty much means the base is the same, but my exponents are different. So for example, if I had 2 to the 3rd power times 2 to, let's say, the 4th power, all I would have to do is the base stays the same, but I would be adding the 3 and the 4 together to get 2 to the 7th power. Why is that? Because this is just telling me, again, the exponent just tells me how many times I have a base, and that's being multiplied together. So 2 to the 3rd just means I have 3 2's being multiplied together. So 2 times 2 times 2. And 2 to the 4th, 1, 2, 3, 4, and they're all being multiplied together. So essentially I have the same base. It's the same 2, 1, 2, 3, 4, 5, 6, 7, multiplied by itself, that repeated multiplication 7 times. So that's what it means. So notice I'm just expanding it to show it. But in this case, I want to know, in which one is it always true? And the one that makes it always true is 1, where notice I have x to the 2nd times x to the 3rd. So they are just adding 2 plus 3 together to get that 5. In 2, the reason why, so in case you couldn't see that, again, they just add it together to get x to the 5th. But for choice 2, the reason why it doesn't work, I have the 3 to the x times the 3 to the 2nd, but that should have been the same base 3, and then you're adding the x plus 2. Notice because they put a 9 there, that's what makes it wrong. You can't multiply the bases. The base will stay the same. For 3, notice it's the same number, but they're just putting that negative sign in front. And unless that z is equal to 0, this would not always be true. So I can't just have 2 squared is the same as, it just doesn't work. It only works when z is equal to 0. So it has to always be true. And for 4, I have 7 to the a times 7 to the b. So again, using that rule, I would have 7a plus b, not 7 times 7a times b. So that's what matters there. And looking at the next one, number 4 here, you just have an expression you're trying to find its equivalent, and they've just simplified it. So I'm just going to start by looking here. I'm going to distribute first, and then I'm going to add. So let's start there. And I'm going to distribute and I get negative 2x squared. And then I have the same one, negative 2 times negative 2 is positive 4x, and negative 2 times 1 is negative 2. And from there, I can now add that next set. So add 3x squared plus 3x minus 5. And remember, I can combine the like terms, so the negative 2x squared and the 3x squared, those are like terms. So when I add them together, I end up with 1x squared, or just x squared, plus 7x, and then I negative 2 and negative 5 combine to make negative 7, and that equals 4. I do have some kids who, when they write the entire thing out, like let's say you distributed and you would have gotten this part, and then you probably would have decided, I'm going to distribute the positive 1 to get 3x squared plus 3x and then minus 5. I would just say, if you got to this point, look to see which ones are the same, and you can see like these two are the same. So I would just put them next to each other. And then you can see that they will combine together to just give you just that 1x squared. And then let's change the color over here. Here, the next set of like terms. So I have 4x plus 3x. And again, you're just combining like terms. So that's a positive 7x. And then let's negative 2 plus negative 5. And when you combine those, you get your negative 7. So there you have it, two different ways. One looks more stacked together, but you could have also just written it out as one long one and just identify what your like terms are. And then remember, you combined your like terms. You just had to remember what to do if you have positive or negative terms. All right, let's hit pause here and jot this down into your notes. All right, let's look at 5 and 6. Again, let's look at number 5 and 6. The answers are 1 and 2. All right, stay here if you got either one of these wrong. We'll start with number 5. With number 5, we're looking for which sum is irrational, meaning when you add them together, you're going to end up with a number with decimals that no matter how we try, it's never going to end, and it doesn't follow a pattern. So that means it is not a rational number. Or you can look for the ones that are not square numbers. Okay, so you can kind of look at it that way. I have the calculator here because you can either use a calculator if you're unsure how to simplify these, or you can just look for your square numbers. And just looking at here, the ones we are definitely sure are square numbers, because they're very common, I'm just highlighting here. If you're not sure about 900, you can use your calculator, hit second, and the square numbers where it's red right now, and you can just put 900 in, and you'll see that, yep, 30 times 30 makes 900, so this is also a square number. And notice the one that does not have a square is number 1. So that's my first easy way to just identify which one is going to be irrational. All right, so let's say, for example, you're trying to do it just by hand, and we're going to look at number 1. I'm going to do it by hand first and then using the calculator. I have negative 2 square root 12 plus square root 100. We know that this is equal to 10. 12 is not a square root, but I can separate it to two factors where one of them at least is a square root, which is the 4. Square root of 4, we know, is 2. So, oops, let's get rid of that. So negative 2 times 2, and it's just 3 is going to stay in the square root sign, plus 10. So negative 2 times 2 is 4. So 4 square root 3 plus 10. This is definitely going to be irrational. And if you want second verification, put it into your calculator. So here's negative 2 square root 12. I hit my little arrow on the outside. And then I'm going to put my square root. Oops, I forgot something. Let's go back for a second. I forgot the plus sign. Okay, there we go. Let's clear that one. Let's do it all over again. -2 square root 12, go outside, plus, really silly mistake to make, but I do it all the time. I sometimes forget to put that little plus sign, and now plus second square root 100. There we go. Now it matches, and when you enter it, see you get this long number 3.07179677. So it keeps on going, and there's no pattern here. This is a non-terminating, non-repeating decimal. That is irrational. And you could have taken any of the other ones and typed it in. Let's say, for example, you're typing in number 4. You can do the same thing. You would just type it in, and you can just verify. So here's 49, go to the outside, plus 3 square root 121. And see, this would have been a nice equal 40. So that's just another way to verify it if you were not sure. So you can try simplifying it by hand. You can try identifying which are square numbers, and you can try identifying which one of these numbers is going to have the irrational, because it either gives me a square root 2 or a square root 3, or as I put it in my calculator, I'm going to get something non-terminating. All right, let's look at number 6, and this one is just a simple equation. We want to find the solution. So I'm going to start by just rewriting it very easily first, very carefully. Okay, and the first thing I want to do is I'm going to deal with this little 2 on its own first, because I want to balance it out. So I'm going to subtract. I'm going to make a 0 pair by subtracting 2 on both ends. So this makes a 0 pair on this side is equivalent to 0, and on the other side I'm going to end up with 14 minus 2, which is 12. Okay, now you'll probably notice I want to get to that x, but this is really nagging me. So this number, this term on top being divided by 3. So again, to deal with that, I'm going to multiply by 3, because 3 divided by 3 is going to give me 1. So I'm going to multiply this term by 3, and I'm going to multiply this term by 3. So 3 divided by 3 gives me 1. So now this is going to leave me with 4 times x minus 5 is equal to 36. This is something you're probably more familiar with. That fraction sign freaks out a lot of kids in the beginning. So don't worry about that part. Just make sure this part is super clear. And all I did was I just multiplied that entire term by 3, because that entire term was being divided by 3. Now I can distribute, and I get 4x minus, so 4 times -5 is -20. Okay. And now I'm going to make a 0 pair by adding 20 to both sides. So this makes a 0 pair. So now I have 4x is equal to 56. I'm just going to move it to the side here. And to get my x isolated, I'm going to divide both terms by 4. So x is equal to, now if you want to do the long division, you can. We do have a calculator, so you could just do this to get to 14. And done. Alright, so again, the hot spot for this one honestly really just is, a lot of kids get freaked out by seeing this. This makes it look super complicated. Don't worry about that yet. Once you deal with that too, once you make a 0 pair, we can deal with this by, instead of dividing it by 3, we're just going to multiply it by 3. And that's what makes that term more simple. Alright, hit pause and jot this down into your notes. Alright, let's look at 7 and 8. The answer for 7 is 3, and the answer for 8 is 3. So these are pretty short. So let's start off with the first one. Again, stay on if you have a challenge. So starting with the first one, we're dealing with exponential rapid growth and decay. So here we have a breed of rabbits that is doubling its population every 2 years. We want to know how to model that increase over 2 years. So it's doubling every single month. So just thinking about that is kind of like that rice problem. If I was graphing this, it might start off, let's say we're starting off with just one. We start with just one, and then all of a sudden we have two. So it seems linear, but then now we have 4, and now we have 8, and then we have 16. So it's rapidly increasing. So it's definitely not linear, so we can get rid of linear. Notice that because it's doubling each time, my number is going, it went from 1 to 2 to 4 to 8, it'll go to 16 to 32. It's growing very rapidly. So we know it's exponential. It's definitely growing, it's increasing, so I'm not going to say it's decay, so that's why it's exponential growth. In number 8, we're looking for the degree of the polynomial. So we're going to, first things first, you're going to order this. We're going to order the terms from highest term to lowest term. So you're going to look at the exponents. And I'm going to start with the biggest exponent first, which is this one here. So 4x to the third, and then minus x squared, and then plus 2x. Because even though we can't see it, it will just be x to like the first power. So this is the greatest one right here, the greatest degree. So that is why it is 3. Okay, that is the degree. Hit pause and jot this down into your notes. Let's look at 9 and 10. For 9, the answer is 2. And for 10, the answer is 3. So check with your answer, with your work. Stay on if you had a challenge. All right, we're going to start with the first one, which is 9, where we're looking for the zeros of a function. In other words, we're looking for, when we graph this, kind of like wherever the roots are, whenever this happens, when y is equal to 0. So how are we going to find that? All right, so we're going to look at this part over here. So we have f of x is equal to x times x minus 5 times 3x plus 6. So if any of these in here, these parts here, is a 0, because I'm multiplying. So let's say this is 0. So 0 times any number, I'm going to end up with a 0 on this side. So if this is a 0, I'm still multiplying. The whole thing is 0. If this is a 0, the whole thing is 0. So what I'm going to do here is we're going to set all of these to 0. So I have x is equal to 0, x minus 5 is equal to 0, and here 3x plus 6 is equal to 0, because those are the 3 things that can happen to make 0. So the first one is easy. When x is equal to 0, this is 0. So that's our first one, so we get 0. So x minus 5 equals 0, so let's solve for x. We're going to add 5 to both sides. So x is equal to 5. There's our second one. And we're going to do the same thing over here with this one. I'm going to subtract 6 on both sides to make a 0 pair. So now 3x is equal to negative 6. And now I'm going to divide both sides by 3. X is equal to negative 6 divided by 3 is negative 2. So I'm looking for so this is true when x is equal to 0, when x is equal to 5, and when x is equal to negative 2. And that is choice 2. All right, with the next one, I kind of like the next one a lot because we want to know what is the y-intercept, what is the b of the line that passes through these points. So because they're giving you these points, we're going to use our equation for slope. M is equal to y2 minus y1 over, again, the changes in x, because we want to find out what the m is. Once we know that, we're going to plug it into the formula y equals mx plus b. We're going to take any of the points and plug it in, and once we have our m and one of the points can give us the y, the x, we can solve for b. So that is going to be our goal, okay? So we're going to start by using the slope formula, and I'm going to put in my points. So y2 is negative 1 minus 5. So where am I getting those? Here's y2, here's y1, and I'm subtracting them. And now I'm going to do the same thing with x2 minus x1. So x2 minus negative 1. All right, negative 1 minus 5 is negative 6. And if this is bothering you, this is where, again, just you can go and use your calculator if need be, and you can get the answer. Especially with this next one, negative minus negative 1. So this is the same as saying 2 plus 1, which is 3. So this is an additive inverse, meaning I'm turning it into an addition problem, and the opposite of negative 1 is positive 1. Okay? So then what is my m? M is equal to negative 6 divided by 3, or negative 2. All right? Now that we have that, we're going to go to our other formula. So this was part 1. And now let's use the point, let's use negative 1, 5. Okay? And we know that m is equal to negative 2. So y is 5. So 5 is equal to negative 2 times negative 1 plus b. So 5 is equal to negative 2 times negative 1 is positive 2. So 2 plus b. We're going to solve for b. This is a 0 pair. So 3 is equal to b. There's our answer. And you may be saying, like, well, what if I chose my other line, the other point? You could have done that too, and you would have just done the same thing. You would have gotten, I'm going to try and make it as, I'm actually going to use this as a space up here. Y equals mx plus b. So you would have had negative 1 is equal to, our m is negative 2 times our x is 2 plus b. So negative 1 is equal to negative 4 plus b. We're going to add 4 to both sides, and we end up getting 3 is equal to b. Same answer. All right, so hit pause and jot this down into your notes. I hope that these strategies and these solutions are making sense to you. And again, if you have questions, just put them into the chat. All right, we're going to look at number 11, and for number 11, the answer is 1. So let's jump into this problem. I'm going to start by looking and reading the problem carefully. Nancy has just been hired from her job. Her company gives her 4 choices for how she wants to collect her salary for the first 8 years of importance. The 8 is important. Each function below represents 4 choices for her salary in thousands of dollars, where T remembers the number of years. So remember, we want to know after 8 years, which pay plan should Nancy choose? And the 4 choices are there. So what I'm doing is we're going to look at the 4 choices and to see which one makes the most sense. So let's start with the first one, which is A of T. And remember, time is 8. So when it's been 8 years. So 2 to the 8th plus 25. You can use your calculator if need be, but 2 to the 8th power is going to give me 256. And 256 plus 25 gives me 281. Now remember, it's not $281, it's 281,000. Okay, because these are in the thousands of dollars. So now let's look at B. So again, when 10 to the T, or 10 to the 8, after 8 years plus 25. And this one is pretty straight algebra. 10 times 8 is 80 plus 25, which gives me $105,000. So let's try C to the T, which is equal to the square root of 400 times T plus 80. So square root 400 times 8 plus 80. So you can use your calculator for the first part, and you're going to get the square root of 3,200 plus 80. And when you do that in a calculator, I just rounded to the nearest hundredth, so 56.57 plus 80. And when you add those together, I get 136.57. So $136,570. and we'll do d of t. And this one was a long one because it had that 2 times, and all I did was substitute the 8 in. 8 plus 1 squared minus 10 times 8 plus 50. So the first part is 8 plus 1 is 9, so 2 times 9 squared minus 80 plus 50. 9 squared we know is 81, so 2 times 81 is 162 minus 30, because I just combined the 80, negative 80 plus 50, and that equals 132,000. So now that we have this, and if it helps, you can put in the commas if it helps. So this is the comma, and you can clearly see the one that gives her the most was a to the t, which is 1. All right, so there it is. So we have all the choices there, and again, you can use your calculator. All I did was substitute 8 years every time I saw t and then solve. It super helps for your work to be clear and organized though, so that's why I wanted to make sure that you can see how clearly organized my work and thinking is here. It helps me follow along and be able to go through the problem. All right, hit pause and jot this one down into your notes. Let's look at 12 and 13. The answers are 12, 2, and 2, both of them. Nice and easy. All right, we're going to start with number 12, which has to do with a sequence. And we're looking at the third term, and the sequence is 25, and the fifth term is 625. So I think of this as I have a sequence of 5 numbers, and I'm looking for what is the common ratio, like what is happening to these numbers as I go through each sequence. So here's A1, the first number. I have no idea what it is, but I know that the second number, I don't know what it is. The second term, the third term I do know is 25. I don't know the fourth term, but I know the fifth term is 625. And I know that all these numbers, to get to the next one, because I'm talking about ratio here, I'm multiplying between these numbers, so by the same number each time. So whatever this number is, I'm multiplying it with each one. Okay, so to find my common ratio, like something, I could already see there's something happening with 5s here just by looking at it, but let's say you didn't know that. I could have taken the fifth term and divided it by the third term. So in other words, I can do 625 divided by the third term, 25, and that gives me 25. Okay, and that's really telling me what r squared is. That's my ratio, because remember here, that means I'm taking 25 times r and then times r again. So that's why it's r squared. So times r will give me this number, and times r again gives me this number. So now I can start thinking for a little bit. If 25 is equal to r squared, then let's do the square root. R is equal to 5. Okay, and let's see if that makes sense. So 25 times 5 gives me 125, and 125 times 5, 5 times 2 is 10, plus 2, 5 times 1 is 5, plus 1 is 6, 625, boom. So yep, these numbers here are being multiplied by 5. Okay, so if I know that, you can use that. I want to make this look clearer. This is 125. So if you know that, you can work backwards by saying, now then let's divide by 5 to find the common ratio. So 25 divided by 5, so A2, the second one, would be just 5. And now divide it by 5 again. So 5 divided by 5 to get this number will give me 1. Okay, so in this one, all they were asking us though, like we did all this math work, but what is the question asking us? They're asking us, what is the common ratio? And that we figured out right here. The common ratio was 5, which is choice 2. Okay, so I just went above and beyond just by figuring out the whole sequence, but really all they wanted to know was what the common ratio was. Let's look at number 13, and we have a box plot, box and whisker plot, and it's telling us summarizing data for the amount of snowfall, and they want us to know what is the interquartile range. So when I'm thinking interquartile range, they're figuring, I'm looking at the box and I'm thinking, what is the difference from one end of the box to the other, or from this, from Q3 minus Q1. So interquartile range means I'm taking Q3, the right side of the box, minus Q1, which is the left side of the box. That's it. So with Q1, the number is between 100 and 120, so 110 minus 60. So the interquartile range is equal to 110 minus 60 is 50. And there you go. That's it. Hit pause and jot this down into your notes. Let's look at number 14. We have 4 functions represented, 2 equations, a graph, and a table. And we're looking for the smallest minimum value. The answer for this one is 1. So how do we know? We'll start with the easy ones first by looking at the graph and the table. And it's really easy to see where the minimum is on the graph here. Here it has -4. And it's pretty easy to see on the table, the lowest point here is over here. I'm looking at the y values on the -5. That's my lowest point. So these two pretty easy. But how do you know the other two? So I would say graph it. And then you're going to look for the minimum values. All right, so that's going to be my method for this. So I'm going to just jump into my graphing calculator. I'm going to go into y equals, and all I'm going to do is I'm going to just type in my formula. So x minus 3, close it up, squared, minus 7. So that's the first one. And I'm going to put both of them next to each other because why not? So x squared plus 6x plus 3. And so you could just graph both of them and look at them if that helps. Like I could already see the blue one is lower than the red one, but I don't remember which one is which. So I'm going to go to second and table so I can see them, and now it's way easier. So I can see the blue was my y1, and you can look to see which one had the lowest value. The smallest value of my y1 was the -7, and the smallest value in the y2, which was the red, is so far it looks like 3. Okay, so I want to just check in and look through all of them because I want to just check with my red one first and trace. And because I can see this one is at -7, which is the lower one. The blue one was the lower one. And when I'm checking on the red one is higher up. So it's not necessarily 3. It looks like it's a little bit higher than that on my graph. It looks like it might be about -6. Right away, I know what's the blue one, which was equation 1. So there you have it, the first one. All right, so let's hit pause and jot this down. Again, super easy when you have a graph or a table, but if you don't, you can just put the equation right in and you can actually just make sure you know which is which. Like, so for me, I had to see like, well, the blue one is lower, but I don't remember which is blue. So you can hit second, hit graph again, and I can look at the blue table, and there it is. I can find my number -7. So that was the lowest point. And then if I go towards my reds, I would have to keep on, like I would probably need the negative numbers to figure out what those were because that one wasn't working for me. All right, so let's hit pause and jot this down into your notes. All right, let's look at the answers to numbers 15 and 16. We have 2 and 2. All right, we're gonna jump in with number 15, which is another sequence problem. And I noticed we have an equation that made us in the sequence of -2, -5, -8, -11, 14, etc. And I want to figure out which equation represents that sequence. So one thing I noticed is there's a common difference between each of these. I noticed that each time the number is getting smaller by 3. So -2, I go down 3, I get to -5. Down 3, -8. Down 3, -11. Down 3, -14. So this is a common difference of -3. All right, super important. So now I'm just going to go to the formula page. I'm not going to go into it here. And the typical formula I'm going to use is A1 is equal, A of any number is equal to A1 plus that common difference and minus 1. Now we know that our difference is -3. So all I would have to do is plug that in. And what is my first term, my A1? I started off with -2 plus my difference of -3 times n minus 1. Looks a little messy, so let's clean this up. An is equal to -2 minus 3 n minus 1. So I just cleaned it up just because I didn't like how it was really looking. And when you look to see which one matches, here it is. This one has my A1, which is 2, and it has my common difference, which is equal to 3. Okay, and that matched what we had right here, our original one, before I started cleaning it up. Okay, but notice I was prepared in case they did distribute it out and make that into just a -3. I was ready for that as well. So -2 minus 3, I had that ready as well. Okay, but they're both equivalent. Let's go to the next one, and we have a dot plot, and they want to know which statement is true. We have mean, median, and mode. Okay, so our three let's see, central tendencies. We know our mean is our average, which we're going to have to calculate. So we're going to look for the sum of all our data points, the sum of all the data divided by our n, the number of data points. Okay, so I would add all of those up. So luckily 0 plus 0 plus 0 is just 0. 1 plus 1 plus 1 is 3. 2 plus 2 plus 2 is 8. 1, 2, 3, 4, 5, that's 15. I'm just adding them here to make it easier. And because I could make very simple mistakes here, and I'm just going to add these 3 together first. So 3 plus 8 is 11. 11 plus 15 is equal to 26. And then I'm going to add these here. So 8 plus 10 is 18. 18 plus 6 is 24. So the sum of all of these points is 50. 26 plus 24 is 50. That's all I did. And how many points did I have? So this is where the counting comes in. I'm just counting how many points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So divided by 20. So 50 divided by 20 is 2.5. So that's our mean. Okay. Our mode is the easiest one. That just means the one that pops up the most. So I'm just going to look for which number is the biggest one. And that's this one. The 3 comes up the most. So our mode is equal to 3. And our medium, we're looking for what's in the middle. All right. So which one is in the middle? Let's erase this for a second.
erase this for a second because I think we know how we got there. And all I'm going to do is I'm at 20 numbers here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So half of my numbers are here and half of my numbers are here. Okay. So how do I figure out what my middle number is? It's between 2 and 3. And so what's between 2 and 3? 2.5. Okay, so I want you to just really notice all I did there was I just looked for the middle value and add 10 equal numbers here and I have 10 equal numbers here. So I know that my middle number has to be the average of 2 and 3, which would have been my middle 2.5. All right, so now that I know these three values, the one that is true is my mean and my mode are the same. They're both 2.5. My mean and my median are both 2.5. My mode is 3. Said that wrong. So 2 is the correct choice. Hit pause, jot this down into your notes, and if you want to see how I found the mean again, you can just go back. All I did was add up all those values together and divide it by 20 because I had 20 numbers. Let's look at number 17. There's only one here. We have students in Ms. Smith's class are asked to describe the graph of g of x and f of x, and we want to know which is correct. The answer to this one is 4. So let's figure out why it's 4. And what we're going to do here is we're actually going to graph. These are functions, and we have our base function f of x, just a regular x squared, which we know is just going to be, oops. If I'm doing just a regular x squared, it's going to look like this. So what happens when we have g of x is equal to 2 times x minus 3 squared? Now we could just think about all the different ways we're changing this. Like we know like this is going to do something to the graph and this is going to do something to the graph. So my advice to you, if you're in a very stressed situation where you're nervous or you may not remember this, and I know a lot of kids who are watching this video, if you didn't get 4, that's probably what happened. So I would say this: let's use our graphing calculator. Let's actually graph it. We know that a regular parabola would be the f of x, just the x squared. And so we're going to go to our y equals, and notice that all I did was I typed them in. So 2 parentheses x minus 3 squared, and then I did the x squared. Notice that this one is going to be blue because this is my y1, and this one is going to be the red one, my y2. And when we graph it, you can see that the red one is my base, but my blue, so what's different about, if this is the original x squared, it looks like it's moved over. Let's change the color for a little bit. It's moved over, it's shifted by 1, 2, 3. So it's shifted 3 to the right. And it's also skinnier. Like look at it carefully as you're tracing through it. You'll notice that the parabola, the blue one, is skinnier than the red one. Okay, so that's what's happening here in our picture. So now when we look at our choices, Ashley says that g of x is wider. We know that that's not true. It's not wider. And it did not go to the left 3 times. So Ashley is completely bonkers. She just got it backwards. Beth said it was narrower, which is true, but it's shaded to the left 3 times. So both things have to be right. She was right about narrower. Carl said the graph is wider. We know that's not true. And it's shifted to the right 3 times. That is correct. But Don said it is narrower, which is true, and shifted to the right 3 times. All right, so that's one thing we can see. Like, so now knowing that and thinking about this here, in terms of shifting, anytime we're seeing, and I'm just going to put in, just so you see f of x. So anytime you see something like x minus h or x plus h. So if you see this, this have to do with the shifts. This is going to mean if it's a minus h, it's shifting to the right h times, and if it's plus h, it's shifting to the left. And that's how many times. So if it's x minus 3, it went 3 to the right. If it's x plus 3, it goes 3 to the left. Okay, so we have that first one. And then the second one is the a. So if there's a number in front, like this 2 over here, if you have a number in the front, as long as it's positive, it's going to stretch it differently. It's going to vertically stretch it up. So it's going to make it skinnier. So if a is a number that's greater than 1, it's going to get narrow. If a is negative, it's going to go upside down. And because I don't expect in a high stressed environment, you're not going to always remember this. So I would say graph it and look. And you're looking for, is it shifting left or right, up or down? And is it getting skinnier or is it getting wider? All right, hit pause and jot this into your notes. All right, let's look at number 18. The answer for this one is answer 1. And in this problem, we're looking for a rate of change. We have a graph. We see how Dave is on his bike trip, and we want to know what was the average rate of change miles per hour. So out of all this graph, what is the average rate of change? So I'm going to look at from my start to my end, what was the rate of change? So I'm going to look, so when they said that, I'm thinking of slope. All right, so I'm going to think of my slope formula. My change in x over my change in y over my change of x. And notice we started at 0, 0, so my y1 and my x1 is going to be super easy. And we ended up here. So what is this point? So here, I'm going to go down here. This is like, what, 5.5? So 5.5 and going vertically here between 50 and 60, so 55. Okay, so m is equal to 55 minus 0 over 5.5 minus 0, so that's pretty easy. 55 over 5.5. So m is equal to 10. And if you were unsure, you can literally just put that into a calculator. 55 divided by 5.5, and you will get 10. And that's it for rate of change. Those are the only 2 points. So I didn't have to look at every single interval and add them up together. Instead, I just chose the beginning and the m and used our slope formula. Hit pause and jot this down into your notes. I gave us a lot of room for this one. Number 19, the answer, which expression is equivalent? The answer is 4. So how do we get there? If you got this right, next chapter. If you didn't, let's stay right here. So looking at this one first, you probably noticed that I'm going to have to, if I'm doing order of operations, I have to multiply these 2 terms first, and then I'm going to subtract. So we're going to start with that x minus 5 times 2x plus 7. Now, some people really love to use FOIL. If you want to use FOIL, you can literally write down FOIL and put the first 2 numbers, the outer numbers, the inner numbers, and then the last numbers. So you can do this and then just find the term. So x times 2x is, well, when you multiply them together, 2x squared. 7 times x is 7x. Negative 5 times 2 is negative 10x. And negative 5 times 7 is negative 35. Look to see our middles are going to have like terms, so when you combine them, you get negative 3x. So here I get 2x squared minus 3x minus 35. So we could do that. Me personally, this does get you the right answer of FOIL. I like to use arrays when doing these types of problems. And all an array means is, again, if I was just multiplying these two, I'm just going to show you my array. Here's x minus 5, and here's 2x and positive 7. And now I would just multiply the numbers in there. So 2x times x is 2x squared, 2 times negative 5, and I'm getting the same numbers. But for me, and the way my brain works, it's so much easier for me to see it. Notice, again, I'm just getting the same terms. But I just see things more easily this way. This is just this number, and this is just this number. And then I'm still finding these are my middle terms, and I will still get the same thing. 2x squared, negative 3x, and I combine these terms, and 35. Okay, so either way would work for multiplying the terms. Got it? All right, now I need to subtract minus x plus 5. Okay, so let's write all this down just so we have it. I'm going to distribute. So this becomes negative x, so it's like I'm multiplying by negative 1, and this becomes negative 5. I like to put things next to each other that are the same. That's just me. So 2x squared minus 3x minus x. Because again, I have to slow my brain down a lot so I don't make silly mistakes. That is me. That is the way my brain works. And it really helps me to think about what I'm going to do before I do it. Okay? So 2x squared minus 3x minus 1, so minus 4x, and negative 35 minus 5, negative 40. And that matches this one here. All right, so you can hit pause and jot this down to your notes. It is just basic algebra, but the easiest way to make the mistake is when you're multiplying the terms. So you can use FOIL or an array. To multiply those binomials. You can use whichever one you feel most comfortable with. And then afterwards, please do not forget to distribute carefully. And I always like to combine like terms. But for me, I like to put the terms that are the same next to each other so that it's easier for me to combine them. And just be careful with your positive and negatives. Hit pause and jot this down into your notes. All right, let's look at the answer for number 20. The answer is 1. So how did we get there? Stay on if you need an explanation. If not, move forward. All right, for this question, we're looking for the solution to the equation when is f of x equal to g of x. In other words, the solution for f of x equal to g of x where you see intersections. And you see intersections in two different places. I'm going to put it in red. We see it happening here, and we see it happening here at this other point. So what points is that? We notice it at the point, let's see, 1, 2, 3, 4, 5. So this is 5, 1, 2, 3, 4, 5. So 5, 5. And we also see it over here at 1, negative 3. So we see it happening when x is what? When x is equal to 1 and when x is equal to 5. So that's going to be the solution. F of x, we're looking for when x is equal to what? Okay. All right, so you can hit pause and jot this one down into your notes. A real common mistake that I can see a lot of students making here is they may find when y is equal. So they may have had 5 and negative 3. So if you had picked 3, it's because you chose when y is equal, the y instead, and that was your mistake. Okay, hit pause and jot this down into your notes. Let's move on to 21 and 22. So the answers are 1 and 2. All right, we're going to start with question 1. We have Nicole charging an hourly rate. So she has the rate and with a charge for gas. So C of H, what she charges is C of H plus 5. So just by looking at that, we know it's her hourly rate plus an additional $5 for gas. So this must be the gas, the flat $5 for gas. And this is a rate per hour. So $6 per hour is what I'm seeing here. And the question is asking us to determine the constant rate represents what. That's all they're asking us. What is that constant term, which is what we figured out. That's the gas that she's paying. So that would have been 1. All right. How do I know it can't be the other ones? Because I know that my constant can't be an hourly rate because I would have had a variable next to it. I know that it's not the number of hours because that would have been a whole term. And it's not next to her rate. And it's not the whole total because the whole total would have been the C of H. Let's look at 22. Now 22 I'm going to give myself some space for because it is an algebra problem. And we want to solve in terms of A. So what does that mean? We want to solve for X in terms of A. Just solve for X. That's all we're doing. Solve for X. This is just basic algebra. And I'm going to give myself a little bit of space here and move a little bit higher. So I have 3x minus 7 is equal to AH plus 5. Just putting some space here. I'm doing that on purpose because the first time I worked this out, I needed a lot of space. This is my focus here. That's what I'm focusing on. Because it says in terms of A, so I want the A to stay on the other side. So I'm going to start by making a 0 pair with the 7. So negative 7 plus 7, that will give me a 0 pair. That leaves me with just 3x. And I'm going to do the same thing here, add 7. So I have 8x plus 12. Okay, now I'm going to move my AX over. So I'm going to make a 0 pair here. So I have 3x minus AX is equal to 12. And you might be going, wait a minute, is that right? I thought you just wanted this by itself. What are we doing? What's going on? Don't worry, there's a method to this madness. Notice both of these terms on the left both have x's. So I want to factor that out. So I'm going to put the x on the outside. So it's like I'm dividing both terms. So I'm leaving this with 3 minus a. So you see that because they both had an x, I factored it out. And that still stays at 12. I didn't do anything to the other side, nothing at all. But now what this allows me to do is, now I can divide this side, this term here, by 3 minus a. And then this term by 3 minus a. You see why I did that? So that this 3 minus a divided by 3 minus a just becomes 1. So it just means 1x. And that leaves me with 12 divided by 3 minus a. Okay? So, and that is equal to our answer here, 12 divided by 3 minus a. So just to recap, so you saw what I did. I started by my 0 pairs. I wanted to leave this on its own, so I used my 0 pairs. Then I moved my a of x. I wanted this to be a zero pair, and I had subtracted here. And I had to look here, and all I saw here was that I could factor x because both terms had an x. And once I factored that x out, I can divide that expression by 3 minus a on both sides. And now I have x on its own. Hit pause and jot this down into your notes. This is one of the tougher problems for a lot of kids to grasp. It feels very abstract. So you can just watch it again if you need to see my steps of how I did it. But that factoring is really the key to this problem so that I can do it in terms of a. Let's jump into 23 and 24. 23 is dimensional analysis problem. The answer is 3. And 24 is a function problem with domain and range. The answer is 2. Stay on if you had a different answer for either one of these two and you're not sure why. For 23, it's a dimensional analysis problem, meaning we're changing units. We have a starting rate and we're changing to something else. So let's start by looking at the problem. We have Wade, a runner from South Africa, and he runs 400 meters in 43 and 300ths of a second to set a world record, which calculation would determine his average speed in miles per hour. So we are essentially changing it from this rate, 400 meters over 43 and 300ths of a second, and we're going to do a conversion to get it to miles per hour. Now, we don't actually need to figure out what the conversions are, but what we do need to do is find out which calculation would give us this rate that we're looking for. That's the big key. We want miles over hours. So what we're going to do, and I'm going to zoom in for a second on these. I want you to think about this, and we're going to think what kind of units would we have at the end. Forget the numbers for now. Do not worry about the numbers. Just think about the units. And as you're looking at the first one, think, do I have a unit as a numerator and a denominator? Because if we do, those will cancel out. So a minute divided by a minute, those will just cancel. And looking at this one, I don't necessarily see that. Let me get my pointer. So here I have meters and hours. So my final answer is going to have meters squared times hours, and I'm also going to have seconds times seconds squares times miles. That's not what we're looking for. Remember, we wanted miles to hours, so this one doesn't work. We'll look at the second one, and notice we do see I have a meters here and a meters here. So when I multiply it, I'm going to have meters over meters, and they're going to cancel out. So I'm going to kind of show you what I mean here. So on the top, I would have meters times miles times hours. And on the bottom, I'm going to have seconds squared, because I have seconds times seconds times meters. So these are going to cancel out, and I'm going to end up with miles times hours, which is still not what we want, and seconds squared. All right, so that's what we're looking for. We're looking for a unit in my numerator and denominator so that that pair will cancel out. Look at number 3, and you're going to see a few of them. So for example, I see meters and meters. So let's go away. And I see seconds, numerator, seconds, denominator. So I would be left with miles over hours, which is what we want. All right. So again, this is not asking us to actually determine the speed. We just want to know which calculation would do it. And when we look at number 4, why does this one not work? Although I can cancel out the seconds, I'm still ending up with meters squared over miles times hours. So that doesn't work. So again, this one, although a lot of kids look at it and they start thinking I have to actually do the calculation, that's not what this problem is asking you to do. It is literally just asking which calculation would give you that. And my look for this is look to see where do I see units that will cancel out, and it will cancel out if you see a unit in my numerator and then you see the same unit in the denominator. Those will cancel out. All right, hit pause and jot this down into your notes. Okay, so let's look at number 24, and I want to give myself some space because I am going to use the graphing calculator, but I want to do some sketches here to talk about it, so I don't have to do screenshots here. We want to know which function has a domain of all real numbers, which means my x has all values like left and right. That's my domain, so everything, all the numbers to the left, all the numbers to the right. But then on the other side, it also says my range is greater than or equal to 3. So either my y values are greater than or equal to 3. So if I'm thinking about a sketch, I don't care, like for my y, I want something where it's up here. Because over here, this is where y equals 3. And it can go as far left, as far right as I want. I don't care about that. My domain could be any number left or right. It can go x is from negative infinity to positive infinity, but my y has to be greater than 3. All right, so that's what I'm looking for to be true in these functions. So what we're going to do is we're going to sketch. Let's look at it in the graphing calculator and let's sketch them all out. So I'm going to put all of them in here. So we'll start with the first one, which is negative x plus 3. And let's look at what that looks like. And when I sketch that one out, number 1, we notice that my domain is fine. My x can go left and right. But notice that because it's doing this way, it's not following my range. I only wanted the ones that have over here where y is greater than or equal to 3. So that's why this one doesn't work, because of my range. Okay, so my range is not true here. That's the error, because I have values where it goes where y is less than 3. So let's look at number 2. We'll go back to y equals. Let me clear this out, and I'm going to put x squared plus 3. And that one looks promising. Like looking at my graph, it's a parabola. So 1, 2, 3. Notice at 3, so that's my lowest point. So that satisfies the two things I want, where it can be equal to 3 and everything above. So I love that. And my domain is fine going left and right. So that's why 2 is the correct answer. But let's say you went to the other ones and you still weren't sure. So you go back to your y equals, and we clear this out and we look at 3. So now we have 3 to the x power, and we graph that one. And this one goes this way, and even though the domain is fine, notice my range is where it's not working. And if you're not sure why, you can go, we can go and graph it. Let's look at the table, and you can see that I have values where y is equal to 1. That at 0, y is equal to 1, so I know that this doesn't match my range. So let's go back to y equals, and let's look at number 4, and we have an absolute value. I had to remember that, how do I find my absolute value numbers? So I had to go to math. And I think yep, there it is. I moved over to numbers and I see it now, so you can hit enter. And now I can put the x plus 3 in there. You can graph it, and what do you see? What do you notice? It's fine for our domain, but not our range. Because you can see it clearly reaches a point where y is equal to 0. And so that's why numbers 1, 3, and 4 don't work, and 2 is correct. So I used a combination of our calculator as well as what we knew about domain and range. All right, hit pause and jot this one down into your notes, and we're going to start jumping in and looking at our constructive response questions. Let's jump into our first 2-point problem. Remember, there are 6 of these. All our multiple choice were also worth 2 points, so there were 48 possible points just in multiple choice. So now let's jump into this one, and we're looking for the solution where we're solving algebraically, where we get x is less than or equal to 15. So that would not only the solution, but we also want to see the work to justify this. So if you got the solution, you would have at least 1 point, but your work also has to show it. So let's see how we got there. So I'm starting off with 5x minus 2. I put in just my formula. I'm going to start by distributing. And this is where you can make decisions about what it is you want to move, what it is you want to move over, and which constant you want to move, which term with an x do you want to move. So in this case, I kind of want to just add 10 to both sides to make my zero pair. Doesn't matter which one. And here I'm going to create a zero pair. So I end up with 2x is less than or equal to 30, and now I'm just going to divide by 2. And that's how I get x is less than or equal to 15. So that's it. If you had chosen the opposite term, that's fine. You just had to ensure that you have the correct zero pairs, and that when we are adding or combining any like terms, that you're doing it accurately considering your positive and negative numbers. But in the end, that's the solution you would have gotten. Or if you had done it the other way around, 15 is greater than or equal to x. Hit pause, jot this down. If you had this, you would give yourself a full 2-point credit. If you had some type of error in there, you may lose at least 1 point if you had some type of calculation error. All right, let's look at the second 2-point, our final solution, where g of negative 3 is equal to negative 6. Let's see how we got there. We needed to evaluate when g is equal to negative 3. So g of negative 3 is equal to, that means every time I see an x, I'm going to put a negative 3 every single time. So negative 3 to the third power plus 2 times negative 3 squared minus negative 3. So places where I can see a lot of small places for error. One, I can see this happening where a student might just put negative 3 instead of minus negative 3. That could happen. And I can see mistakes happening here where we may be evaluating, figuring out which one to do first. So we'll start with the negative 3 to the third power. Negative 3, if it was just 3 to the third power, we know it's 27, but it's negative 3 to the third power, that would be negative 27. Okay? Why? Because negative 3 times negative 3 would give me positive 9. And then if I'm multiplying that by times negative 3, that's where I'm going to get negative 27. Okay? Negative 3 squared is just going to be 9. And additive inverse minus negative 3 is going to be like a plus 3. Okay, so continue to evaluate. Negative 27 plus 18 plus 3. So we have it pretty easy. I'm going to just add these two together because it's a little easier in my head. Oops, nope, Siri, did not come in. So negative 27 plus 21. And then when you combine these two together, we're getting negative 6, which is why our final solution, when we have g of negative 3, we get negative 6. So you give yourself not only a point for the solution, but for the work itself. Now, if you have just one small computational error, like let's say you put in a positive 27, you might risk losing a point. But if you have multiple errors, you risk getting 0 points in here. This is also a place where if you needed to use your calculator, you could, but make sure that you are not using your calculator just to get the final answer and writing negative 6. So I would just use it for the small parts like negative 3 to the third power, I would double check that with my calculator and then just write that down. But make sure you're writing down the rest of the expression so that an adult can see how you're simplifying it. If you put this entire thing into a calculator and just put negative 6, you're not going to get credit because we can't see how you actually did it. And it doesn't show that, it doesn't demonstrate that you know how to evaluate this expression. Hit pause and jot this into your notes. I love this problem here because it's really about the explanation, and what they're looking for in this explanation is, do you know what makes a function a function? So let's think about our definition. We know that a function can have one and only one value of y for every x. So somewhere that's what they're looking for. So only one output, which is really my y. For each input, which is my x. Okay? So knowing that, I can choose any number, because they're saying state a number for x that makes this true, as long as my number is not any of these numbers here repeating, like a 1, a 0, or a 2. I can make this x any number. Okay? Because I can't have, if I put a negative 1 in there, that would mean that my answers for negative 1 would be 1 and 5. That's the problem. So again, think about your inputs and outputs. I have negative 1, 1, only one number here, 0 and 3, negative 2 and negative 4, and whatever this x is, it's going to make a 5. As long as it's not any of these numbers giving me a 5, I can pick anything I want. Okay? And so that's important. So any number that is not a negative 1, 0, or a negative 2 can make R a function. Alright, so I can pick 18. I can pick 27. I can pick 8. Any of those numbers. So let's say I decided on 18. I can pick 18 because it's not a negative 1, a 0, or a negative 2. So this one does have multiple possible values. But what they're looking for is your explanation. Your explanation is what's key. It's where, like, yes, you could put any number in there as long as it's not a negative 1, a 0, or a 2. But they're also looking for the explanation. So if you have a great explanation that shows you know what a function is and why it can't be those three numbers, then you're going to get the full credit and that you stated the number. Okay? So love this problem. It's just looking to see that you actually understand it and not just that you're doing something with numbers like a trick. We really want to see the level of understanding and that you can clearly explain that and demonstrate that to a person. Hit pause and jot this down into your notes. I absolutely love two-way frequency tables. So we just have to read through this pretty carefully to understand, like, to get some of the numbers, and then we'll be able to figure out the other ones. So let's start from the beginning, and we have a survey of 150 students were taken. So out of everyone, there were 150 total kids. Okay, it's determined that 2/3 of the students play video games. So we got to figure out what that means. So what is 2/3 of students? So if I was doing 2/3 of 150, or 2/3 times 150 over 1, that's 300 over 3. So that's only 100 kids play video games. So that's going to be important to note. So 100 kids play video games. Of the students who play video games, 85 of them also use social media. So, okay, so 100 kids play video games, 85 use social media. So knowing this, 85 plus what gives us 115. So that's how I get that first number. And I like these because these are like Sudoku, so I could actually do this part next. So I know that 100 play video games, so how many do not play video games? 50 do not play video games. So again, I love these little puzzles. So 85, we said use social media. Of the students that do not play video games, 20% do not use social media. So I want to know what is 20% of 50. So I'm just multiplying 0.2 times 50. Well, 2 times 50 is 100. 0.2, so that's just 10. So only 10 do not use social media. And again, you can use your calculator for this. So if 10 kids don't use social media, 10 plus what makes 50? 40. And now I can do my adding across to figure out the next part. So how many kids all together use social media? You're just going to add these two together. 85 plus 40 is 125. And then you'll add the next one. 15 plus 10 is equal to 25. And you could always just check with your numbers. 85 plus 15 is 100. That's right. 40 plus 10 equals 50. That's right. 125 plus 25 is 150. That's right. And we already checked these and we saw that was right. Oops, sorry Siri. And we saw this was right. And we saw this was right. So all you had to know was, could you figure out like a fraction or a percent of a number? So anytime we want a fraction of a number, we're going to multiply. And if we want a percent of a number, we are also going to multiply. But remember, turn this into a decimal first. Hit pause and jot this down into your notes. So I'm going to do something really, really different. This is only a 2-point problem. It is completing the square. A lot of kids hate completing the square because it's something that you only do like for maybe a week at most in Algebra 1 and you almost never use it again. So I'm going to take a very visual approach because I think if you see the visual, it's going to help you. And then I'm going to do it the more algebraic way on the right. Okay? So first of all, completing the square literally means, could I visually complete a square to solve this? I'll show you what I mean. So I have x squared plus 10x minus 30 is equal to 0. So if I'm starting this off, I have, here's my first square, x times x, that's what makes it x squared. And I'm going to take that 10x and I'm going to put half of it over here to complete a square, and half of it, like half of it's going to be here and half of it's going to be there. Okay? So because I have 10, I'm going to split it in half. So I'm going to have 5 of them here. 1, 2, 3, 4, 5. And I'm going to put half of them here. 1, 2, 3. 2, 3, 4, and 5. Okay? So this is 5x, and this is 5x. And now I just need to figure out this part over here to finish the square. Okay? So what I'm going to do is, here's my x squared, here's my 10x. And I'm going to just move that negative 30 to the other side is equal to 30. I'm just moving it over, okay? What would I need to fill this box is my question. What would fill it up? I'm going to change the color for a little bit. So I would have 5 rows of 5. And that's, so 5 rows of 5, which is the same as I would have 25. So x squared plus 10x plus 25 would make the square. On the other side, So I'm adding 25 to this left side. So I'm going to add 25 to the right side. Okay? So because remember, this had to be equal. So on this side, I had 30. So this was my 10x, my x squared plus 10x. And on the other side, I had 30. So if I added 25 here, I'm also adding 25 here. So now what do we have? So on this side, I now have x squared plus 10x plus 25 is equal to 55. All right, so I'm gonna stop there for a second so you can see, so you reckon, so just pause, think about all I did, okay? This was the only thing I had originally there. This was my yellow, my x squared, and here was my 5x and my other 5x. And then I added 25 to both sides. All right, now that I have this x squared plus 10x, 10x plus 25, now that it made a square, I can represent this as x plus 5 squared is equal to 55 because it literally made a square, which is why I can write it in this way. So I'm going to find the square roots of both sides. So I now have x plus 5 is equal to the square root of 55. And now over here I'm going to subtract 5. And on the other side, I'm going to subtract 5. So x is equal to negative 5 plus or minus the square root of 55. There we go. I've completed the square. And I found all the possible values. So it could be 5 plus the square root of 55. It could be 5 minus the square root of 55. And I can leave it like this. I don't have to go much further. Now let's go at it algebraically. So x squared plus 10x minus 30 is equal to 0. First thing they usually tell you to do is, if it's not truly a square, we're going to move this part over. So we ended up with x squared plus 10x and is equal to 30 because you added 30 to both sides. Okay? Then they usually say you're going to take this number and you're going to half it and then squared. So I'm going to add, here's that 10, I'm going to break it in half and then I'm going to square it. So all I did. So what is 10 divided by 2 squared? So 10 divided by 2 is 5, and now 5 squared is where you get the 25. So you're with me so far? Now notice we did that here where we put half of it here and half of it here. That's all that's happening by saying take 10 and break it in half. And then once you broke it in half, you're figuring out what does that square have to be? Well, it would be 5 times 5. Because half of 10 is 5 and half of 10 is 5. So 5 times 5 or 25 would complete the square. So once you do that, on the other side, you're also going to add that 25. That middle part sounds so confusing, but you see why the visual helps me to do that. But now you can see how you got to 55, and from here on, the steps are still exactly the same. Now we're still doing x plus 5 squared is equal to 55. Now we're going to find the square root of x plus 5 squared. And so you get x plus 5 is equal to 50, square root of 55. We're going to subtract 5 from both sides, and we get x is equal to negative 5 plus or minus the square root of 55. And that's it. I personally really like the visual completing the square because it helps me remember that I'm just putting like that half b term times 2 was always super confusing, but when I literally remember like, oh, I'm putting half on this side of the square and half on this side of the square, it clicks with me in a very different way. And then it's easy for me to see, like, to literally draw it out and make the square, figuring out what I'm adding to both sides. Okay, so hopefully that really helps. You can use either way, and this would make a 2-point problem. So you can hit pause and jot this down into your work. If you got this all done, give yourself 2 points. If you made a small error somewhere, subtract 1 point. But if you have multiple errors or is completely not mathematically sound, then you have to give yourself 0 points. All right, here's our last 2-point problem. We need to factor this completely. Our final solution is going to be, let me write it here, 5x times 2x plus 3 times 2x minus 3. That's our final solution for this, but they also want to see how we did it. So let's jump in. We'll start from the beginning. So 20x to the third power minus 45x. The first thing we're going to look for is, do you see any common factors? Any at all? And so when I think of just my 20 and my 45, I know there is a common factor of 5. So I could divide both of these by 5. And now I think about my x's, and I could do at least one x from both. Okay? So I can pull out a 5x. I'm going to put that here on the side. And 20 divided by 5 is 4. And x to the third power divided by x is x squared. And on the other side, 45 divided by 5 is 9. X divided by x is 1. So we're up to this part. Okay. Now, so we figured out the first factor here, and we can literally see it here. The second thing to notice is that you have dots here, difference of perfect squares. Okay? So we have, so you want to be able to see that. And so I can separate this. Forget the 5x for a second. Because I see that 4 is a perfect square, and even 4x squared is a perfect square. So I can have 2x and 2x. And here I have a 9, which is a perfect square, but it's a negative 9. So I have a 3, a plus 3, and a minus 3. And that's how I got that one. So if you, or you could have had 5x, here's 2x, and here's 2x, and you could have had minus 3 plus 3. Either one would have been fine. But there you go. Now it is completely factored. So if you did all of this, you will get all 2 points. If you probably factored just a 5x, you could have gotten a point, but you had to have all those. So if you did 5x times 2x plus 3, like if you forgot one is positive, one is negative, you're probably going to deduct yourself a point. So give yourself a score of a 0, 1, or 2. And that is it. This is the last 2-point problem in the Regents. Right now we're jumping into our 4-point problems. There are 4 of them. With this first one, we're just graphing a system of equations. That's all they're asking us to do, and they give us the 2 equations in there. I think the clearest way to do this is to just go into your graphing calculator, and you can start by graphing both. So I'm going to start putting it in there. Here's x squared minus 3x minus 6. And then in our second one, we just have x minus 1. Remember, I like putting in, so I remember, this is my blue and this is my red. And I'm looking for places where they intersect. And I can already see that my second one is going to be linear. It's going to be a straight line somewhere. And my first one is going to end up being it's a parabola because I have x squared in there. So I'm expecting, like, if I end up having a parabola and a line, it might touch 0 times, 1 times, or 2 times. So that's what I'm looking for. I'm either going to have 1 solution, 0 solutions. I might have 2 solutions. Okay. So we're going to graph this. And boom, there you go. Just like I said, we have a straight line. and we have a parabola. I want to get some points in there that make a ton of sense. So I'm going to second and graph because there are some points here that I want. I'm going to start with just the blue one, and all I'm going to do is literally with the blue, I'm just going to put in some points. So when x is 0, I get -6, and when x is 0, I get -6. Okay. So I'm graphing that point in there. And then when I also notice that when x is 3, I get -6. 1, 2, 3. Okay. So I have those in there. I'm going to look for my lowest point as well. I get -8 and -8 at 1 and 2. So when x is 1, I get -8. See, x is 1, -8. And I also get at 2, I get -8. Okay, and somewhere underneath that, they kind of get together. Okay, and I also want to see where else do I want. I want to see, do I get any y equals 0s? No, I don't have that one, but I'll get another point in there. Let's get when x is 5. 1, 2, 3, 4, 5. I get 4. 2, 3, 4. Okay. And that's also probably going to be true in the opposite direction. All right, so at -2. All right, so I kind of got this going for me, where I can kind of see my parabola moving. And with the other one, pretty easy. I'm just going to put some points in there. So 1, 0. Whoops. So sorry. I got when x is 1, I get 0. When x is 0, I get -1. So this is just going to be like a regular x minus 1. So it's linear, just x minus 1. So that's easy enough for me to graph. Okay. So when do they actually touch? So do they have any times where their points are exactly the same? Let's look at the graph again. And I see it kind of happens at that other point. So now I can just trace it. Like, where are they touching? And they're touching around here when x is, it looks like when x is 1. And here at 5, 4. And somewhere around where x equals 1. So I need that point too. So we'll go to my graph, my table. So on my other part, when x is equal to -1. So that's what I need. I need when x is equal to -1. And that's where it's happening. So luckily I can just put in that solution. So y equals x minus 1. So when x is -1, -1 minus 1, y is equal to -2. So this is -1, -2. And I could even, if I wanted to, I can go and I can put in the points on the other one. So y is equal to x squared minus 3x minus 6. So I can just put in -1. So y is equal to -1 squared minus 3 times -1 minus 6. So negative times 1 times -1 is 1. Plus 3 minus 6. 1 plus 3 is 4. 4 minus 6 is -2. So yep, that's the other point. So our solutions are -1, 2 and 5, 4. And I'm really approaching this as if like I only had the tools that I had here. So here's my graph. I want to make sure I have it so just so you can see I have my y equals x minus 1, and then this one is my y equals x squared minus 3x minus 6. And I have my points in there so we can see them. Here's my -2, 4. Here's my 5, 4. Here's my -1, 2. Its opposite would have been over here, which is 4, -2. And then these are the points that had 3, -6, and 0, -6 over here. And then these are my other points, my 1, -8, and my 2, -8. So they're all my points, so I have it in there. Alright, so in order for me to have like all 4 points here, I graphed, not only did I state the coordinates, but I graphed both of them. I enlisted lots of points in there. I showed both my solutions are there. All that has to be true in order for me to get all 4 of my points. Alright, so hit pause, jot this down to your notes, and you can see clearly how you can use your graphing calculator to come up with some points to help you with your graph. Let's look at number 32. Here we have a table that shows the amount of money a movie earns, millions of dollars during the first 6 weeks of the theater. Our goal is to figure out we need to be able to write a linear regression equation for the data set and round it to the nearest hundred. So this is absolutely going to be a calculator problem. And what we're looking for is the relationship between the weeks and how much money it's making, like if it's a strong or weak correlation. Once we have that, we're going to look for a few more things in the stats. We're going to look to see if there's a correlation coefficient, which is a very specific term. And we're also going to look to see how strong it is to align with best fit. So we're going to look for that as well and state what kind of correlation it has. So what we're going to do, you're going to go into your calculator, which I have ready, and you're going to hit stat, go to edit, and I've already typed in my numbers for L1, which are my weeks. So those are my X values, and L2, I decided to put in, I put in the values here for Y. So that's all I did going down. The other thing you're going to want to make sure is that this is already in diagnostic mode. So the way to check for that is go to second and hit mode. It's right next to second, hit mode. And you're going to scroll down to where it says stat diagnostic. Oops. Go down to where it says stat diagnostic. And I am just hitting the wrong button, so let me use the pencil instead. And just make sure that it's set to on. Alright, you want to make sure that is on. Sometimes it's off when you turn on the calculator, make sure that's on. Alright, let's go back to stats for a second. So now that we have our information, we've seen it, you can go to stats and hit calculator, move to the right of edit where it says calculator, and go down to number 4, and it says lin reg. That's for our linear regression. And just hit enter. And this is giving us all the information that we have. All right, so here's our stats. Edit. We have it. Hit stat again. Calculate. 4. And there we go. So now this is all the information we need. So to start off, we're going to write it in form. I like to write everything on the page, even though we see it right here in the calculator. But remember, we need to demonstrate it on the page. Our equation is going to be in y equals ax plus b form. We have our values for a here, so we just need a and b. And remember, we're rounding to the nearest hundred. So for a, it's -37 and 57 hundredths because there's a 1 behind it. So we're going to round it to 57. And for B, we have 215 and 67. We're rounding it up to the nearest hundredth. So they're going to look for that for our equation. And now we're just going to substitute it. So y is equal to negative 37 and 57 hundredths plus 215 and 67. Oh, don't forget to write the x. I kind of forgot to write that there. Okay, so now I have my equation. And there you have it. All I did was sub in my a and my b. And now for the next part, I have to state the correlation coefficient. That's my r. So r is equal to negative 0 and 9/8. And there's a 4 behind it, but we want to the nearest hundredth, so it's negative 0.98 hundredths. I stop there. These are rounded. And now we just have to state whether or not this is a strong or weak correlation. So here's what we're doing. We're looking at like a number line. Here's 0. And we're going from negative 1 to 1. So what we're looking for is R closer. This is what you're actually looking for. Well, I would ask the question like, where is R? That's what I'm thinking in my head. Where is the R? And my R is definitely negative, and it will be like around here. So negative, like it's very close to negative 1. So this tells me there is a strong, and the closer it is to the ones, it is a strong correlation. If it's closer to negative 1, it is a strong negative correlation. If it's closer to positive 1, it is a strong positive correlation. So now I can state what kind of correlation is this. With a correlation coefficient of negative 0.98, there is a strong negative correlation. So let's talk about what that actually means. What does it mean to have a strong negative correlation? It just means that as the weeks are going up, like think about this, as my weeks are going up, the amount of money earned goes down. That's literally what we're noticing with the data, right? And it's strongly correlated. These are strongly connected to each other. So but this is all I would have to write. That there's, with a correlation coefficient of negative 0.98, there's a strong negative correlation. And I can give a reason. R is very close to negative 1. Done. And that's all I really need here. So remember what you're looking for. If you have a problem like this where they're asking you to write a linear regression equation, you have to use your calculator. Use this video if need be to help you find the actual steps, so that you can get this information that you see on the calculator side. That means being able to put in the right information to L1, L2, make sure it's in diagnostic mode, and then go to your stats part so you can get this part, the linear equation part, and jot it down. Once you have your A and B, you can write your equation, and it's probably going to ask you to write the coefficient, and please make sure you're checking that you're rounding to whatever place value they're asking. You don't want to lose a silly point over a rounding error. And that's it. Hit pause, look at your work, and decide if your work is it strong 4, like there are no errors, everything is absolutely correct and clear, you've demonstrated you know how to do this on your calculator and what it means, or for the errors you're finding, decide for yourself what would you give yourself on a scale of 0 to 4. Hit pause, rate yourself, and then we'll get into question 33. All right, for number 33, we need to solve this with a quadratic formula, which I've written down. So we already have it, and we have our original formula, which is already written in ax squared plus bx plus c form. So think about your coefficients. So our a, the coefficient is 3. For b, the coefficient is negative 10. And for c, the coefficient is 5. So right off the bat, I will say there are a ton of kids who will forget that it's a negative 10 and just write 10. It happens all the time. So this is a place where we need to really be accurate and attend to precision and be very careful. So slow yourself down as you're jotting this down. All you're going to do is substitute in the beginning. So another place where you can make very silly errors. So negative b means I want negative, and then my b is negative 10. So that's a place where we can make a very silly mistake. Plus or minus negative 10 squared minus 4 times 3 times 5. All over 2 times 3. So that's the first part. So now we're going to just start evaluating it. So with the first part, negative times negative 10. So this just is a 10. So 10 plus or minus the square root of negative 10 squared is just 100. And then minus 4 times 3 is 12. 12 times 5 is 60. So minus 60 over 6. So far, so good. So now let's keep dealing with 10 plus or minus. Let's deal with that. What's in that parentheses. 100 minus 60 is square root 40. And over 6. So this is where I can't do anything with square root 40. So let's see if we can split this up. So I could do, are there any squares in there? And yeah, we can do 4 times 10. We can do that. And that would give us x is equal to 10 plus or minus the square root of 4 is 2. 2 square root 10 over 6. So we're at a really good place here so far. Is there anything else we can do with this problem? Just trying to think through. I could divide everything by 2. So I could get 5 plus or minus square root 10 divided by 3. So x can be equal to this. And I can see some kids, I'm wondering, and this is where I want to see, like, to get the full 4 points, would I have to do 5 plus or minus square root 10 divided by 3? Or what if you had just left it as 10 plus or minus 2 square root 2? Would that have counted? So it's just something that I want to look into, because I think they will give you full credit for either answer, but I want to just double check to see what the state would give. All right, we're going to solve a system of inequalities, and we have to actually graph them. So they give us the 2 equations, and to start off, it really helps if you get them into y equals form, especially if you're going to put it into your graphing calculator. The second one is actually the easier one to change. So y equals, I'm going to actually just put this one on the right side. So y minus x is greater than 1. We can change this just moving the x over. So y is greater than x plus 1. Like, you're literally just adding x to both sides. So that one's super easy to graph. And we're going to have to move the other one around too. So we have 3y plus 2x is less than or equal to 15. I'm going to want to move, let's move the 2x over. So 3y, I'm going to subtract 2x minus 2x plus 15, and then I'm going to divide by 3 on both of them. So on this side I get y is less than or equal to negative 2/3 x plus 15 over 3, or y is less than or equal to negative 2/3 x plus 5. So we have more or less two equations that we can now graph. So now I can go to my graphing calculator and we can put both of these in. So here's the first one. So we have negative 2/3 x plus 5. And I want to put the 2/3 in parentheses. So 2 divided by 3 x plus 5, and then on the bottom x plus 1. Now notice I'm leaving it as if they're just y equals for both of them, and I know that this is my blue on this side, this one's going to be my red. So let's graph them. Boom, here we go. Awesome sauce. So with my blue line, I want to do my blue line first. Here I have my, let's trace it. Here's my first line over here. I can see they intersect right about here at this point where, okay, so they're intersecting kind of there, but I can kind of graph this in. I need some points. That makes sense. And if you're tracing it, this one makes sense. So when x equals 0, y 5. 1, 2, 3, 4, 5. So that point, and I need another really good point. Do I have another good point here? No. So I'm going to want to go to my table to find some easy points. So I have 3, 3. That's awesome. 1, 2, 3, 1, 2, 3. And I have 6, 1. And I have 9, negative 1. So I'm just going 6, 1, 2, 3, negative 1. Okay, so this is pretty helpful for helping me just find some points. So 5, 0. So I notice I'm seeing a kind of pattern where I'm going down 2 over 3, down 2 over 3, down 2 over 3, which I can literally see here. So I can do the same thing up 2 over 3, up 2 over 3, 1, 2, 3, so that I have at least this part in there. Oop, I hit my mic for a second. Alright, so this helps with this one, and it could be a solid line because it is y is less than or equal to. So here's this one. I'm going to put in my equation just so they can see it, and this one was the original. 3y plus 2x is less than or equal to 15, and I want all the points under. So I'm just going to shade it this way. Okay, and now I'm going to do the same thing with my other one, which is much easier to graph. So for the second one, the red one, so much easier. Starting off, I want the points 0, 1. When x is 0, y is 1. So that's easy enough. And then this one is just increasing by 1. Nice and linear. I love that. So easy to graph. And in this one, my y is greater, So I want all those, and I can see they overlap over here, so this is my solution set. Now, here's the thing I will say about this one. This one had to be a very dotted line. Because notice it's not when we looked at it here. And I'm just going to put y is greater than x plus 1 there. Okay, and that's it. So I've graphed it and I have my solution set in there. I have my points. I made sure that this one was dotted, was dashed, and this one was solid. And because my pen doesn't have an eraser, and when I do an iPad, I had to kind of erase it and put it in there so you can see it together. But I have it in there. All right, and then the second part says state the coordinates of a point that is in the solution. So I just have to pick anything that's in here, any point that's in there. So I'm just gonna randomly choose, let's choose this point here as a solution, which is 0, 1, 2, 3 as a solution. So they just said any point. So there are multiple answers for this one. I just had to choose anything that fit. And then I just have to prove that it works. So I will just go into, I give myself a space. So y minus x is greater than 1. And then I will just put the other one. And now I just put my points in there. All right, so 3 minus 0 is greater than 1. Yeah, 3 is greater than 1. That is true. And I'll do the same thing to the other side. 3 times 0 plus, oops, sorry, not times 0. 3 times 3, because that's my y, plus 2 times 0 is less than or equal to 15. So 9 plus 2 is less than or equal to 15. 11 is less than or equal to 15. And that is true. And boom, that is it. That's all you needed to get these last 4 points. You needed to graph both of them correctly. You had to make sure you found the solution set. And then you had to make sure that you chose a point in the solution set and actually justified your answer to show that both it satisfies both inequalities. And I'm even going to write that 0, 3 satisfies both inequalities. And that's it. Boom. There you have it. All right, so go back and look at your work. Look to see if you had a 0, 1, 2, 3, or 4. 4, absolutely everything has to be perfect. But if you had at least one error somewhere, start deducting a point if you had an error either in your graphing or in the solution set, or if you made a mistake with your inequality, where like one is solid, one is dashed. So those cannot be places you lose a point. Hit pause and check in with your answer. Okay, we're up to the very last problem, which is usually a systems of equations. Is our 6-point problem. Lots of nuances here, lots of places where you can make errors, so let's read it very carefully. Courtney went to the coffee shop to purchase lattes and donuts for her friends. One day she spent a total of, let's do it in a different color here. She spent $15.50 on 4 lattes and 2 donuts. The next day she spent $18.10 on 3 lattes and 5 donuts. All prices include tax. So in this first part, we want if x represents the cost of 1 latte, so x are the lattes and y is a donut, we need to write a systems of equation that can satisfy this. So using the first set of information, we can say x is 1 latte and she bought 4 lattes. So 4x plus she bought 2 donuts, so 2y is equal to $15.50. And then the next day she spent $18.10 and she had 3 lattes, so 3x plus 5y. That's all you have to do for the first part, was just write 2 equations. Then in the second part, she thinks that a latte costs $2.75 and a donut costs $2.25. Is she correct? And you have to check to see. So pretty much what I'm going to do here is I'm going to check it and put 4 times 275 plus 2 times 225. Is this equal to 550? So on my calculator, that's what I'm going to do. 4 times 275 plus 2 times 225. And yeah, this equals 1550. So it matches the first one. So now I'm just going to check the second one. 3 times 275 plus 5 times 225 equals 1810. Because you want to check both. So we do the same thing. And this part is a no. We end up getting $19.50. So my answer is no. Courtney's numbers only satisfy the first equation, but not, oh, that looked like hot for a second, but not the second. Okay, so they just want to see again that you can justify it to see whether or not it's true. So they're looking for that. All right, so now we actually have to solve it to find the cost of a latte and a donut. So looking at both here, both equations, I have 4x plus 2y and 3x plus 5y. And you get to decide what you want to use for this. Like, do you want to use substitution? Do you want to use graphing? In this case, what I would like to do is I'm going to add them together. So I'm looking at these for a second, and I can see, because I want to do elimination. I want to eliminate something. And by looking at it, I don't see a lot of things I can eliminate. Here I have a 4, and here I have a 3. And here I have a 2, and here I have a 5. But what if I wanted to eliminate these? I can just multiply by the opposites coefficient. So I'll show you what I mean. So I'm going to multiply this one, this whole thing, times 3. And this whole thing times 4. Because that way I want, if I multiply this times 3, I'm going to get 12. If I multiply this times 4, I'm going to get 12. And then I can do some I can subtract and I can do some elimination. All right. So now I end up getting 12x plus 6y is equal to 4650. And on the other side, I get 12x plus 20y is equal to 7240. And now I can subtract these. And when I subtract, that's what I wanted. These eliminate. That's what I wanted. And when I subtract, so now that I'm subtracting, this is going to become a negative sign so that I can subtract. So negative 6 minus 20, I'm going to get negative 14y. And down here, again, this is going to be a negative sign because I'm subtracting it. And if you're not sure how, you can literally just use your calculator. 4650 minus 7240, and you get negative 2590. I want this. I want to get rid of the x's because now I can solve for y. I can divide both of these by negative 14. So y is equal to, divided by 14, $1.85. So this is the cost of a donut. It's $1.85. Okay. Now that I know what a donut is, I can substitute that in. So I can use any equation now, which I will. Let's do the easy. Let's do this one. 3x plus 5y equals 1810. Doesn't matter which one you use, but now I know that 3x plus 5 times $1.85 is equal to 1810. So 5 times $1.85. So 3x plus 925 is equal to 1810. Now I can subtract. I'm going to bring this up a little bit just for space. Now I can subtract the 925 from both sides. So I get 3x is equal to, let's see, 1810 minus 925 is equal to $8.85. And I'm going to divide both sides. It's not by 3x, by 3. And I get x is equal to 2.95. That is my latte. There we go. So now I want to do a check. I know what my donut costs. I know what my latte costs. So I'm just going to go and check into both equations again. Just so I have it. So 4 times 295 plus 2 times 185 is equal to 1550. Check it with your calculator. 4 times 295 plus 2 times 185 is equal to 1550. That is correct. 3 times 295 plus 5 times 185 is equal to 1810. Do the same thing. Boom, 1810. So I know I am correct. So there, that is it. That is a full 6-point answer. Check to see, I just lowered this a little bit just so you can see all of it. But that's all we have here for our points. So they're looking for 1, can you write these 2 equations? So we get points for that. Can we get this here? Do we have, is this true, yes or no? And can you justify your answer? So you had to say no and justify. So this is another place to get 2 points. And then you have to actually solve the system of equations to find the cost of the donut and latte. So it doesn't matter which way you use, as long as you were able to algebraically prove, and they say algebraically, so I can't use a graph. So algebraically meaning you had to use either elimination or substitution to solve this. And then I don't want to lose any points, so I check my work. And that's it. So now you can take all your points, score yourself. How do you think you did on a 0 to 6? 6 being absolutely perfect, 0 being I left it blank or I had no clue, it made no sense. And add up all your points together. We're going to figure out what your final score is. And that's it for the Regents. So now you're going to go back in and just check to see what all your points were. Remember, for the multiple choice, these were all worth 2 points each. So you would add up all those points and then all your constructive response points. And the total, the highest points you can get is your max is 82 points on this. Now the way this is broken up, once you have all your actual points, it will tell you your performance level. You're going to add all these points up and those will be your raw scores. Just so you know, that's the raw. So let's say you added up all your multiple choice points, your constructive points, and let's say you had 40 points. You will look at your chart and you go, okay, 40 points, that will equal to about a 70 scale score on the Regents, which will give me a level 3. In terms of scoring, the way they for pass or fail, it's anything that is a 3 or higher would be passing the Regents, so of a 65 or higher. That's what they're looking for. I always try to say don't aim for the lowest bar. Really push yourself to get as many points as you can. And this video is here for you so that you can really make sense of the mathematics. I know you can do it even if it's in a higher pressure situation. So whatever you got for today, use that information to figure out what topics you need to study and practice. I am going to make sure that we also add the August and January Algebra 1 Regents so that you can get additional practice. And it's just like anything else, the more times you do it, the better you're going to get. The first time I took my driving test, I failed it. So I was super discouraged, but the next time I got much better at it. But I will say that I practiced a lot. I almost practiced the same way you're practicing right now to see how many points I would get in order to pass the test. So you're going to do the same thing here. I hope you found this video super helpful. Share it with your friends if you did, and look out for our August and January Algebra 1 Regents test. And if you're in geometry next year, you can look out for our geometry Regents. That's it for now, Math Marbles. I hope to see you next time in geometry. Take care. Bye.